Hello students, today's topic is linked list. So in this video, I'm going to explain you about the basics of linked list and the types of linked list. So first we'll understand that linked list and what is a linked list, why there is a need of linked list. As in my previous video you have seen, we have studied the data structure, that is an array. As we are having an array as a data structure, then why there is a need of another data structure, that is a linked list? Because we are facing some problem with the arrays, and that problems we need to overcome in a next data structure, that is nothing but a linked list. So basically the linked list are invented to overcome the problems of arrays. So to understand the meaning of linked list, first we need to understand which problems we are facing with the arrays. So what are the problems with the arrays? First problem with the array is size is fixed. As we know that arrays we can create, when you declare an array, you need to give the size of that array. When you compile a program, that time compiler knows that what is the size of that array, and depending on that it will allocate a memory for array. Once the size is fixed, once you have given a size of that array, you cannot change the size of that array. For example, suppose we have created an array of 10 elements. So in that array of 10 elements, suppose you are storing only single value, then there is a wastage of 9 elements, space for the 9 element. Okay, so once you have defined a size of that array as a 10, you cannot reduce the size of that array. That size becomes a fixed. Similarly, suppose user requirement is to insert 11 elements. So as the size of that array is fixed, you cannot insert the 11th element since you have allocated the size for only 10 elements. So that is why we are facing the problem with array is the size of array is fixed, and you cannot, once you declare the size of that array, you cannot change the size of that array, you cannot reduce the size of array, and you cannot increase the size of array. Okay, so that is a problem we are facing with the array, and the same problem we are going to overcome with the linked list. Second problem is array atoms are stored at continuous memory location. So to allocate an array, we need a continuous memory location. I'll give you one example to understand this problem. Suppose I want to create an array of 100 element, 100 integer element. To store the 100 integer element, we need 200 byte of space, but that 200 byte of space should be continuous. If the continuous space is available, then only we will be able to create the array. But suppose on a disk, the 200 byte of space is available, but it is a non-continuous, means 100 byte of space is available at one position, 50 byte of space is available at some other position, and 50 byte is available at some other position. So in total we have a 200 byte of space, but since it is not a continuous memory, we cannot allocate such a memory using arrays. So whenever you are going to create an array, so for that purpose you need only continuous memory. If it is a non-continuous memory, you cannot use that space, and that time it will show you error message, you cannot create an array. So that is a second problem we are facing with the arrays. The third problem we are facing with array is insertion and deletion at a particular position is complex. So how complex? In array operation we have seen that suppose you want to insert the element in between. Consider we have 100 element in our array, and we want to insert the element at 51st position. So what you need to do? You need to shift all the elements from 52 to 100 towards the right side. Then only the space will be available for the 51st location, and you are able to insert the element at that location. And it is a very complex complex thing. To move all this, to shift all the elements towards the right or to move all the elements towards the left becomes very difficult. That is why the insertion and deletion at a particular position is very difficult in terms of arrays. We are going to overcome all these disadvantages of arrays in a linked list. That is why we need another type of data structure which is called as a linked list. So why only linked list? Because linked list is not, the size of linked list is not fixed. As per user requirement, you can increase the size of linked list or you can decrease the size of linked list. In case of arrays, we are not able to increase the size of array and decrease the size of array. If you are having an array with a bigger size and you are going to save only a few elements in that, then there is a wastage of memory. But here, as per the user requirement, we are going to allocate a space. That is why the size of linked list you don't need to mention at a compilation time. At runtime, as per the user requirement, you can allocate the size of that linked list. So that is a first advantage of a linked list over the array. Second advantage is data can be stored at any place. Okay, as I explained you earlier, suppose the non-continuous space is available on a disk, 100 byte at one place, 50 byte at other place and 50 byte at some other place. Then that non-continuous space you are able to utilize whenever you are using the linked list, but such a space you cannot use using the arrays. So for linked list, what we can say in a simple language, for linked list we don't need a continuous memory. If it is a non-continuous memory, then also we are able to utilize a space. Insertion and deletion are simple and faster as compared to the arrays. What difficulty we were facing in arrays? Insertion and deletion at a particular position is very complex. It takes a longer time to insert a element at particular position, but that drawback we are overcoming in a linked list. We are able to insert and delete a element at using very simple method and at very high speed. So these are some of the advantages of linked list over the arrays. That is why we need another type of data structure which is called as a linked list. Then we know that why there is a need of linked list. Now we'll understand what is a linked list. What is the structure of linked list? A linked list is a collection of nodes with a various field. It contains a data field, an address field or a link field. So data field is also called as a info field and the link field is also called as a address field. So this diagram will show you the representation of representation of a linked list. Linked list contains two major parts. Data part. So in this diagram you are able to see two parts. The linked list. Linked list is a collection of node and each node contains a data part. Data part is also called as a info field or info part, and the second part is called as a link part or link field. So why we need a data part and link part? Because in a data part the actual value we are going to save in a data part or info part. So which value we are going to say store in a link part? As arrays. Consider the example of arrays, because we'll compare this linked list with the arrays. So what happens in arrays? Suppose you want to create an array of 10 integer element. So 10 integer element means at each and every location you are going to store the integer value. That value could be 2, 4, 6, 8, 10 like this. The same data part, value part we need in a linked list, and in an info field or in a data field we can store the actual value which you are going to store in a linked list. So it could be an integer also, it could be a float also, or it could be a character also. So whichever type of data you want to store in a field, in a data field, so that type of linked list you can create. You can create an integer linked list, you can create a float linked list, or you can create a structure linked list. The next part of node is called as a link part or address part. So what this address part holds, as I told you, linked list doesn't need a continuous memory. Okay, so as it allocates a memory from the different places, so after this my first node, whichever node is coming, so the address of that node I am going to store in its address part. So as I told you, linked list is nothing but collection of node, and this diagram is showing you only the structure of single node. ओके, सो इस लिंक लिस्ट में हमारे पास 10 नोड्स भी हो सकते हैं, 20 नोड्स भी हो सकते हैं. सो आफ्टर दिस पर्टिकुलर नोड, whichever node is coming, second node is coming, so I am going to store the address of that node in the address field. Okay, this is how we store the values in a linked list. Then there are different types of linked list. Basically there are 4 types of linked list. First type of linked list is called as a singly linked list. Second is a circular singly linked list. Next is a doubly linked list, and the last type of linked list is a circular doubly linked list. So we'll understand each and every type of linked list one by one. So this is a graphical representation of singly linked list. So what is the meaning of singly linked list? It is only just like as a continuous memory. जैसे arrays में हम variable store करते हैं, in the same way we are going to save the element over here. But the thing is that here the list contains the collection of nodes. So in this particular diagram you can see there are 3 nodes. So my first node stores a 10 value, second node stores a 15 value, and third node stores a 20 value. So as I am going to store 3 values in this linked list, so to store 3 values I need 3 different nodes. Each node contains a data part and address part. Okay, so first, what is the address of first node? Below here it is mentioned the address of this particular node. So the address of first node is 4000. So this particular node is stored at this particular memory location. Since it is a non-continuous memory location, first node can store at 4000 memory address, second node can be stored at 1000 memory address, and the third node can be stored at 2000